Extra, extra, hear all about it. Good morning, YouTube. On this Monday, it is 11:13 now in the AM. I'm here today to show you this little diagram that I came up with. You can see I have a large cursor now. It took me, well, it didn't take me a long time to get it done, but I did have to do some searching to figure this out. But I have my cursor now the size that I really want it. I like to be able to see it where it's at and point things out. Now, that's one of the reasons I wanted to do that particular thing was for this illustration here that I have got up on the screen right now. As you can see, this is a diagram of what seems to be, at first glance, the Motorola 5A5 RF section. But if we look down here at the thing right here, it says Model 5A1. And that is exactly what this is from. Now, some research has told me that the Model 5A1 is the same as basically the same. I'm not going to say it's the same radio. But the schematic is similar enough to where it can be used as with my situation. All the parts are the same. And basically the 5A1 is just a battery-only version of the 5A5. In other words, there's no provision for a AC rectifier and things like that. So as such, I thought, well, that would be perfect for me because that is exactly what I'm doing here. I'm not using the AC, and I'm just using the battery, which is a 67.5 volts. Now I do have some 9-volt batteries on the way. Monoprice had a sale going on. They had 2 alkaline batteries for $1.79, and I ordered 2 packs of those. That makes 4 batteries, and I already have 4 of the EBL, I think they are, rechargeable 9-volt batteries, and those batteries only put out like 7.4 volts. And I figure with 4 of those and 4 of the 9-volt, I should have right at the correct amount of voltage for my radio. I think I figured 65 and something, some kind of decimal point. But anyway, it should be close enough for this radio, to power this radio. And if we look at this basically, this is how I'm going to wire it. You can see there is an 820 ohm resistor here going from B minus to ground if you follow the switch here, and that limits the current of both well, not both, the B minus is what it limits. The A minus, which is also connected to ground through that switch, is 1.5 volt flashlight batteries, it says right there. But anyway, and also this here has, I think, been increased as well. This is a 6800 ohm resistor here, 6.8K, and I think the old one was a 2.2 if I'm not mistaken. But anyway, that's what we're going to try. This is the circuit we're going to use to attempt to set up a RF tuner with one filter for IF, and that's the way it's set up. So you can see our AVC here is going out to nowhere, and that's basically what we're going to have set up. As long as we have our antenna coming in to here, where you can see there is a connection point there, and this is where it gets our ground here from that. So that's still good and everything. So we'll set that up just like that. And like I said, everything is set up to you can even see this one's now on the diagram. You couldn't hardly see the other one. You can see this oscillator coil is 1, 2, 3 is in the middle, 4 is up top, and 5 is down here in the corner. So that's how they're set up on the oscillator coil. I've got the coil off and ready to be mounted. In fact, I think I've already mounted it, if I'm not mistaken. But anyway, I just kind of wanted to add this along with what I said today as far as the board that I'm using and things like that, and show you what I'm trying to accomplish here. As I said, this AVC is going up nowhere. We don't need the AVC for our purposes. Eventually, maybe we might try to set it up. Bob has mentioned that the transistor AVC is a positive voltage, and our tube is expecting a negative voltage. Now, for my limited ability to get stations in here where I'm at, I may have one or two at the most that I can get in. I don't think AVC is going to play a big part in that, and in fact, I think I want my AVC as high as it will go. As far as being 0, I think that would be best because that gives me the most gain here at the oscillator mixer, and I think that's the best place to do it, or way to do it. So that's what I wanted to show you. Basically, I want to try to find a switch to use with this so I can turn everything on and off, and I don't have to be wasting my batteries when I've got these hooked up to this device. And that way, once I hit my ground switch, it is a ground switch. I understand that's probably not the way to do it, but this is the way we're going to do it. So, but anyway, you can see our everything. This is everything we need just for this section to operate. After this does its thing, and we receive a station comes in here at the antenna loop, it goes directly into the grid of one of the grids of the IR5 mixer oscillator, and is mixed with the oscillator signal, which comes up through here. And what we have come out here is one of the frequencies we have come out here is 455 kilohertz. I'm not going to go into why we have that, but we will have that here at this first IF transformer. And if we see it's as Rick McWhorter likes to say, magnetically coupled, and that is accurate. I always say inductively, but you know it is magnetic because these are coils. But anyway, at this point here, these 2 points here, we will have a 455 kilohertz IF type signal that we can couple into our next radio, I hope. And that is the plan. So basically, I just kind of wanted to go over this new diagram and show you that it is actually a better diagram for the battery operation, which I'm going to be using. And I think that's going to work out really nice. So I also wanted to play with this software a little bit and show you my big cursor. That's just a nice cursor. So, not going to make a long one. You guys have a great day. Thanks for watching, and we will see you.